Mhm. Welcome, everyone. Welcome to day 2 of the Design Your First Earthen Tiny House Challenge. My name is Verena, and I'm the main teacher, online teacher at Earth Building School. And I'm excited to get into floor plans today. So I'm just going to give it a couple of moments still for people to come on and get organized. And while we're waiting, I'm curious to hear, where are you calling in from? Where are you watching from? And is this your first day, or did you already take part yesterday when we looked at wall systems? So it's very exciting to see the engagement in the group. You might have seen people post their rationales about which wall systems they are going to roll with for the duration of the challenge. And if you haven't seen yesterday's live stream, I would encourage you to do that to help you along with the decision about the technique you want to use for the sake of designing this little tiny house this time around. It will also inform you, about a few things like a wall thickness and so forth. So that should be up in the group yesterday. And you don't have to have watched it for today's lesson to make sense. So just putting that out there. Yeah. So without further ado, let's roll into the presentation. The way I see today's session pan out is I'm going to do a presentation with some slides, and then we're going to do some design work both in an online app and by hand so that you can see how I suggest you do this, and so that we can see if there's any questions. And I will take questions at the end of the live stream and at the end of the session. I will not put too much attention on the chat so that I can concentrate on teaching, but afterwards I will definitely circle back to your questions. So don't be shy. And engagement in the chat is welcome. It helps also boost the live stream online. So don't be shy. Let us know, where are you from? What do you want to achieve with this, and so forth. And let's get it started. So today we're looking at floor plans. So a floor plan is like a 2D view of your building project to start off with. And just before we start, I do need to put a little bit of a disclaimer into this for the sake of this training, to manage expectations in the group, and also to really let you understand who I am and what I can bring in terms of training. So I'm an earth builder, an earth building artisan. I have 30 years of earth building and natural building experience, and we have our natural building company called Solid Earth, which has been running in Whakatu Nelson on the South Island of Aotearoa, New Zealand, since 2002. And the whole time I've also been teaching. So we do in-person workshops, and for the last 3+ years we've also been teaching online, which has been absolutely delightful and has allowed us to reach more people and also engage and connect with people from all over the world. So it's been very delightful and very enriching, I think, for everyone involved. That being said, I am not a licensed building practitioner, so this is basically just relevant for people in New Zealand to understand. There's a licensed building practitioner scheme in New Zealand, so I can't do designs for people, and I'm not certified under this scheme for the very only reason that they couldn't really assess my skill set when I applied for it. So depending on what you want to do with your design, you will have to engage with an LBP. It's not relevant if you're doing a really small building, like what we're teaching here, but just wanting to let you have clarity around that legal requirement. So it is up to you to check that, and we are not really liable for what you design and maybe build in the future. That is really up to you. So I think it's common sense and understood, but just putting this here at the start of the training. Also, um, whatever you choose, if you're actually going to uh, in the future build what you're designing or build something that you're designing, um, it is up to you to decide whether you want to go down the route of getting a building consent or not. It doesn't matter where you're based on the planet. Some people will choose to go the legal route. Some will not have to because their building is exempt. Some people will choose not to get a building consent. But whatever you do, it is really, really important that you design to code so that your building is safe for its occupants. And this is really a value of our school, that we teach to code. Um, and that we explain and make it clear why that is important. And also, just wanting to explain that this is a basic design training. It is not a how-to construction tutorial, and it really goes beyond the scope of this training to answer many questions about how things are put together, like in a practical way, building skills. There have been some questions in the group that go in the category, and just wanting to point you towards the Earth Building School Facebook group. So some of you will be watching from our Solid Earth Adobe Building site. We have an Earth Building School Facebook group, which is more interactive. And in there, if you go to videos, you will see previous live streams that I have done on a number of different topics. So there's a lot of free teaching content in that group if you want to dig deeper. And some of those things are also on our YouTube channel, but the YouTube channel is a little bit of a mess because we actually have two, and that was just Google doing something weird. And I'm trying to get it all into one place. But if you dig around, you certainly will find a treasure trove of other information beyond design. Okay, so why do we start with a really small building? I am assuming, I'm already seeing in the group some of you will go a little bit bigger, but I'm teaching you the 10 square meter approach at this point, for the reason that if you're based in Aotearoa, New Zealand, a 10 square meter cabin will not require a building consent or licensed building practitioner supervision for both types of construction that we're talking about. So that's the solid earth construction or the timber earth hybrids. That doesn't apply to you if you're watching this from other places on the planet, but it just makes it simpler for those of you that are based in Aotearoa, New Zealand. And we start simple because then we can understand the concepts. And you'll see, especially when we get into structure tomorrow, the 10 square meter building is already complex enough to really get your head around the roof structure, for example. So we start small, understand how to read the standards and so forth. And then if you want, you can always scale up and apply what you've learned to a bigger building. And a 10 square meter building, designing and building a 10 square meter building is totally achievable. You theoretically could even do this. Just launching into it with a rough idea and just starting to build. But it is much better with a plan. It's much better because then what kind of materials you need. You can do a little bit of a quantity survey on it. You can do all the things that we're teaching this week, and then you can launch into putting it all together. And I say this from experience because I've done both. So I've launched into it, and we have built several cabins over the years, and the one with the plan was definitely a smoother process. So I hope that makes sense why, even for a very small building, we want to encourage you to have a plan. And today we're talking about floor plans and why do you want the floor plan and what is a floor plan? So imagine you are in a room and you're cutting the room horizontally maybe at 1 meter height. And then you're standing and you're looking down into the room, or you're flying above it, with the ceiling off, and you're looking down into the room onto a two-dimensional thing, your floor. And this is what a floor plan is. So you're looking down, it's two-dimensional, and it gives you measurements. So it gives you the room measurements, and that then gives you the floor plan, the floor area. So in our case, 10 square meters. And developing floor plans is important because that's when we start putting in things like furniture, windows and doors, and so forth. And we start playing around with the dimensions of the room, the length of the room and the width of the room, to make sure that it all fits, and that, for example, you can walk around the bed if you want to do that, or that you can fit in certain pieces of furniture. So we make sure that the measurements fit for the furniture. And we also start thinking about things like standard measurements of materials that you use. So that could be, for example, if you're using timber flooring, for example, in the form of sheets, plywood sheets or chipboard sheets, that you have that, translating that into the ceiling, the same thing. Sometimes you would be using plywood. It's useful to think, how many sheets would I use, and the standard measurements of these materials actually fit, rather than having just this tiny little bit too much or too little that then wastes materials. It's also useful to think about measurements when you're thinking about how to place your doors and windows. And sometimes, especially in smaller buildings, you will be using recycled joinery, for example. So, you would be incorporating the measurements of the doors and windows that you already have into your floor plan, and you make sure that that works. And the other thing that you're checking on a floor plan is the bracing of the building, and I will get to that in a moment, like really explain what that means. And the other thing is the wall thickness. So when we're talking about 10 square meters, we're talking about interior measurements. So the actual floor usable space is 10 square meters, and your wall thickness is beyond that. And the wall thickness can be anything between, let's say, 100 millimeters for a timber frame, or 200 for a timber earth hybrid, to 280 or even more for your solid earth construction, or even maybe a straw bale construction where the walls are much thicker. And a common thing that happens when you're new to design is that you just draw the walls as lines, and that is not realistic, because the walls have a certain dimension, a certain thickness, and it is important that you take that into account when you draw the plan. So there's to explain this to you, what I just said with visuals. If you're new to this, what you can do to find out dimensions of furniture, for example, you can go online and research this. So depending on whether you're working in metric units or in imperial units, you just Google, standard furniture dimensions for bedroom or something, and it comes up with these images that give you standard dimensions. What you could also do is you could actually physically measure a bed or a closet or a bedside table. If there's a piece of furniture that you really like and you want to have in your space, you actually measure that piece of furniture so that you can place it and make sure that it fits. And start making a list of the things you want to put into the room and the measurements, and then that gives you, the measurements to work with. And I'll show when we're in the sketching phase, how we place them and how you can use that list of furniture to play around with inside of your room. The other measurements are the measurements of materials, as I already mentioned. So mentioning a couple of ones that are common, that I find, in small designs, that they are common. So, for example, if you have decided to go for a solid earth wall, which quite a few of you have done, you have told us in the comments that you want to go for solid construction, and you can also let me know in the chat now. Are you leaning more towards solid construction or more towards a timber earth hybrid? How wide how thick are your walls? You can put that in there, then I get a bit of an idea when I'm going to draw. But if you're doing a solid earth construction, the minimum size, the minimum width of your load-bearing wall is 280 millimeters. And the way that translates into thinking about a floor plan into units is that the block works with the 280 millimeters plus 20 millimeters of mortar, so that brings it up to 300. And for the design purpose, we're working in multiples of 300 for the floor plan. That way, if you stick to this, when you're going to build it, you have less cutting in your bricks. And you see here on the slide, it says multiples of 150. That is because the bricks are overlapped. When you lay them, they go, the first one is here and the next one is overlapped by half. So we're really designing to multiples of 150 millimeters, half bricks, which gives quite a lot of flexibility in the design. So that's something to keep in mind when you're developing the floor plan for your Adobe block. So I would suggest every length of wall that you have is a multiple of 150 millimeters. So let's say you have a wall that is 750 millimeters or 900 millimeters and so forth. The other thing that you could take into account is size of plywood sheets. As I said, they're quite commonly used either in flooring or in the ceiling. And the size of a plywood sheet is 1.2 meters times 2.4 here in Aotearoa, New Zealand. Maybe it's different in other places. Research it and try and incorporate this if you're going to use it in a way that you have only part sheets. You don't have a little bit more than, let's say, 4 sheets or something like that you actually make economic use of your plywood. And I mentioned recycled doors and windows. So if you're going to use this for the design of for the sake of the design, you might not know this. So just assume or use something out of your app or look up standard window and door sizes. When you're then going to build and you're using recycled windows and doors, it is very useful to have the exact measurement and then design to that. And why am I putting this in here? It's in our professional experience, we have had clients that actually used recycled doors and windows for an entire big building. And they saved a very big amount of money because joinery is expensive, new joinery is expensive. So they then they knew the sizes of their joinery and they designed the entire building around that. They fine-tuned it to be able to use that joinery, and it was a very good approach to save money. And just to recap this once more, the wall thickness has to be reflected on your floor plan. And if you're designing with solid earth construction, that being adobe or cob, it is a minimum of 280 millimeters for your wall thickness. If you're going to a timber earth hybrid, it's anything between 100 and 200 millimeters. Realistically, if you want to have enough insulation in there, it will be 200 millimeters. But that is really up to you. It depends what the building is used for, on your climate, and so forth. So just have a think about how thick your timber walls have to be in order to perform well for your location. And that brings us to the bracing. So bracing really means bracing is the structural integrity of your building. And bracing means that your building is stiff enough to withstand forces of nature. So this could be in many locations, it can be earthquake. In all locations, it will be wind. A building has to not be able to be pushed over by these forces that nature puts on the building. And you can imagine if your building is like a little box, and you imagine, the forces of nature come in two directions. They come from all directions, but conceptually, we're thinking, it's pushing along a wall and it's pushing against a wall. So you always have these forces coming from both directions of the building, and you have to make sure that the walls in all the directions of the building are strong enough to withstand and to give the whole building stiffness. And really, for tiny homes, this is quite simple, and that's why we start small, is so that you can understand this concept. For tiny buildings, it really means that you have to make the corners at least strong enough. So strong corners, that also translates to bigger buildings, but in bigger buildings, the bracing design is a little bit more complicated. So in bigger designs, you actually have to do a bracing calculation and check all the walls in each direction and make sure that there's enough bracing in each direction. In small buildings like a tiny house, it is mainly the corners. So we will just, keep it simple for the sake of this training and just say you need to have a minimum size corner. But if you want to be sure, if you're scaling and going to a bigger building, like a 30 square meter building, you really want to do this bracing calculation. And both standards that I have linked in the information that gets sent out. So we are working to the New Zealand Earth Building Standard, and we're working to the timber frame standards. Both these standards have bracing calculation. It's a step-by-step process with a worked example. So really encouraging you to have a look at the bracing calculation and how that is done. Wonderful. So just to show you this. So here, this is a three-dimensional depiction of rooms. So it's a little bit further ahead than just your floor plan. But if you just put attention onto the gray, the top of the wall here, this is basically your footprint. It's basically your floor plan, just shown in a little bit of a different way. And this is an image out of the Earth Building Standard. So it is more complex. It's an actual building. It's more complex than a tiny house. But you can imagine that for a tiny house, you could imagine, like this, you just pick one of the rooms and that is your tiny house. So the important thing to understand is that the force of nature goes in both directions of the building. So be this earthquake or be this wind, you always have these two lines, two directions in which stiffness has to be achieved. And for the sake of the tiny home design, we're just looking at corners. So the corner, for example, this front corner here with the two windows on either side, you see that corner is kind of slender. There's a minimum requirement for the corner to be 900 millimeters minimum, 0.9 meters in each direction on the outside of the building. So you can understand that because of the material thickness, the inside measurement will be kind of different. But the outside measurement has to be a minimum of 900. So just pointing out the other corners here, that front corner there is probably stiff enough, and the back corner might be a little bit slender. But you also see how the exterior measurement is bigger than the interior measurement because of the wall thickness. So when you translate this onto your floor plan, just make sure that when you measure the length in one direction of your corner on the outside of the wall, it is a minimum of 900 millimeters. Then another thing which gets asked a lot is, what about a sleeping loft? So we're working with this small 10 square meter building, and some people like to incorporate a sleeping loft. It does make a lot of sense because of the room use. Just be aware that depending on where you are, sleeping lofts are a gray area, or they're actually then something that is not exempt. So exempt of building code. So you need to check that if that is legally possible, if you care about the legality of things. But there is definitely a lot of tiny homes with sleeping lofts, both the ones on wheels and the cabin style ones have sleeping lofts. So I wanted to put this in here because in a way, the sleeping loft is an extension of your floor space. So consider the overall building height. You really shouldn't be more than 3.5 meters tall. There is kind of a ratio of floor area to height in terms of the stability of the building. So stick below 3.5 meters, including the thickness of the wall of the roof structure. And when you're designing with a taller building that has got space for a sleeping loft, I would really encourage you to think about the head clearances and access, and understand, and that already plays into what you're doing today with the roof plan, is like, where is the sleeping loft in comparison to your floor, and how do you get into the sleeping loft, and does that make sense in terms of your floor plan? It definitely adds a little bit more complexity to the design and the construction. You'll see this if you choose to go for a sleeping loft. When we're talking about the roof design tomorrow, it will be a little bit more complex, but it definitely is something that is worth exploring if you want to build something that is very useful. So I just wanted to show you a couple of images of little cabins with sleeping lofts. So we got this from the customcabins.nz and the Fox Cabins, because I thought I just wanted to point out a couple of things here that are important and also interesting. So yeah, let me know in the chat, are those sleeping lofts something that you're interested in? Any ideas for sleeping lofts and so forth? We can definitely keep this conversation going, because you'll find a lot of ideas online, and the whole question about sleeping lofts gets solved in different ways by different designers. And also just wanting to say, you can totally go down a rabbit hole and look at lots and lots of designs online. I would encourage you to focus on your own design and just get this floor plan done so that you can keep up with the challenge. You can always refine it later, and a little bit of creative restraint goes a long way in terms of getting your own creativity going. But that being said, if you look at the cabin on the right top hand side, I find this an interesting solution, because they basically extended the floor space by having the sleeping loft cantilevered, overhanging the entrance, which has a double function of covering the entrance and giving a little bit of weather protection, which is great, and shade. Um, Looking at this, one thing that I can see too is like it will probably be really nice for ventilation because the hot air rises, and sometimes overheating is an issue in these small cabins. So the hot air can escape at the highest point of the building. What I'm questioning here is that the access to the sleeping loft is at the lower end of the mezzanine, and it will be a little bit of a squeeze getting in because the higher end is where the window is. So that might be something that you might not want, or maybe it's not an issue at all. So that's this one. The other one on the bottom, that's you see the inside of this one in the other image. Their sleeping loft is part of the whole building, and you see how the access is actually at the highest point. So you have good heat clearance to get into the sleeping loft, and when you get in, the lower end is at the place where you have the bed. So this is probably a little bit more user friendly. They have the ladder coming down. You would have to look on your floor plan if you have that, where does the ladder end, and make sure that it's not in the way of furniture or a door, or that the access is solved. And another thing that I can point out here on the left is that they have put in the handrail here, so like safety barrier for the mezzanine, which I like. So it's a good thing, to keep that safe. So that's just a few ideas for you there in terms of sleeping lofts. Okay, so in terms of developing concept drawings, so concept drawings means you're creating a concept. They're not your final drawings yet, so it is a creative process. When you're doing concept drawings, you're really problem solving, you're developing your final design, which then will translate into your working drawings. The working drawings are the ones that have all the measurements, and like they're often then really done nicely, so that when you're building you can just look at your working drawings. But today we're doing concept drawing, so it lets you experiment and find solutions, and you can do this by hand totally. Like personally, I'm a hand sketcher. I have an architectural design background. So when I studied architecture many, many years ago, we actually, it was just at the time when computer-aided design was getting introduced, and only half the students got computers. So I trained by hand drawing. But especially for this conceptual phase, the hand drawing can be very beautiful. It can really get your creative juices flowing. For some people, the apps, so the online app is actually easier, because what you'll see when I demonstrate both, you can just change measurements and play around, and you have a library with furniture, and you can just drag and drop that in. So for the sake of today's training, I want to show you both. And only today we're dabbling with an online app. From tomorrow onwards, we're going into the hand drawing, because when you go into 3D plans, the computer-aided design, the online apps get a bit more complicated. So, there's good 3D apps like SketchUp, which are great to use, but, they come with a little bit of a learning curve. So for some of you, that might be interesting, and for others, it is too overwhelming. So we'll just play with a really simple one this time around. And if you're going with the app, I suggested the floor planner. Someone said, "Oh, what is the equivalent for Mac users?" There's another, you can just research that. I looked it up today, and I'm not a Mac user, so I can't really tell you which ones I would use, but it doesn't matter. If you can't use the app today, just go to hand drawing, I would suggest, because we're going into that anyway, moving forward. So you will need a few supplies for this. You will need square or graph paper. And I suggest you get like a soft enough pencil because it's easier to sketch with a softer pencil. So HB or B pencils and an eraser. You might want a calculator, but for a 10 square meter building, that's often not really required. And then I would suggest you get also scissors, because I'll show you in a moment what you can do with the scissors. And something that I got from uni, from architecture school, was using the unwaxed baking paper, which basically lets you draw. It lets you draw, your rough floor plan, and then you can lay the paper over this floor plan and start sketching how you would furnish or how you would change things. So you don't have to redraw the whole thing over and over again. So that's a possibility if you want to experiment with that semi-translucent paper. And another way of really getting your head around this is modeling. So really speaking to different ways of learning and different ways of problem solving, and working with the hand is really a good thing in architectural design, and it allows you to already start visualizing the room in 3D as you're developing your floor plan. So some people can really just visualize this in their minds, and others really get inspired by building a model. And if you're if you're into this and you're going into earth wall construction, you can already use the materials that you didn't actually use for building the building. So you can just go and dig a bit of clay from your garden, or you can use potter's clay and start playing and really finding solutions with your hands. And if you're leaning more towards a timber earth hybrid, you can use cardboard or something. The cardboard sort of simulates a little bit of thickness, especially if you use that cardboard that is a bit thicker with the corrugated things between two sheets of cardboard or something like that. And you can start prototyping. Okay, so that's just ideas, and I will now go into the sketching demo. And for that, I just need to set myself up to share my screen again, because I'm working on a drawing tablet, and it's just switched itself off for a moment. Wait a sec. Yeah, that's good. Wonderful. So let's show you this. And just making sure that you can all see this. Maybe give me a quick comment that you see my graph paper. Yes, the app is called Floor Planner. So yes, so we're live with the graph paper. So I'm just showing you it. You would be working with either a squared paper or a graph paper, and I just have to look over because I'm drawing now. But the first thing when you work on graph paper is that you decide. So just pointing this out here. You decide the your measurements. If you're working, I'm working in metric, so I'm working in meters or millimeters, and you have to decide how many squares is a meter. And for myself, I have decided that 4 squares, so 1, 2, 3, 4, is 1 meter, which then translates into 1 square being 0.25 meters, which is very close to a mud brick size. So they're 0.28, but for the sake of drawing, this is absolutely close enough. So that's, in that respect, that is very easy. And then, you just start thinking, if I have a 10 square meter building, the floor plan is the length of the room times the width of the room. That's how long can the walls be. And a typical building that works, that I know works, in respect to the sizes of the mud bricks and the sizes of plywood sheets, is a building that is 4.2 meters times 2.4 meters. And then we're within that 10 square meter building. So I'm just going to do this for a moment here. And thinking, like 1 meter, 2 meters, 3 meters, 4 meters, 0.2, so like nearly there. Yeah. And then the other dimension being 4.2, so 1 meter, 2 meters, 2.4, so one more. Yeah. So then the same thing here. And let's say this building here is a timber earth hybrid, so we're not going for the full width. If it was a full width, it would be a full square wide, but we're going for the half width. So we're assuming, they're a little bit smaller. You actually then draw your walls to the size that you think. Oh, let's do that again. And you see how I'm putting in the wall thickness, so the material thickness of the technique you're choosing. And the inside measurement is 10 square meters. So this wall here would be, let's be tidy. You put in your measurements, a 4.2 meter wide building, and this one here is a 2.4. Okay. And then that's your very rough dimension of your building. Then you start seeing, does this work with the furniture that I'm wanting to put into this room? And I've already drawn some pieces of furniture down here that I know are the right dimensions for what I want to use. So there's a bed, there's a bedside table, there's a little chair there, and this is like a closet with some clothes hangers at the bottom. When you draw this on paper, you can draw your pieces of furniture on another piece of paper, and then you can cut them out, and you can then place them onto your floor plan and play around with them. It's a very easy thing to do. I will simulate this because I can just grab them and then shift them. So, I'm just going to show you what happens in our own little cabin. So I'm shifting this, the little bedside table is here, the closet is here. We don't actually have a chair, but I'm sure we could put it here somehow. So you see how if you had these pieces of furniture cut out, you could play around. You could see how does it work if the bed faces the other way, or if I want to have enough space to walk around the bed. Not everyone likes just getting into the bed from one side. So play around with it. And when you have kind of an idea of how your room could be furnished, then you start thinking about your windows. So think about, how do I access this building? Where does the light come in? What are my sun angles? How does this building work in terms of windows and doors? And again, you might have already predetermined sizes of windows, or you would just choose standard window sizes, and then you see if it works. So let's say I have a window here. Wait, I need to draw up. Oh, I have a window here, and I have a window here, and I have sort of a big glass door here. And that will, mean these are the walls. Yeah. I personally like having the side of the building that faces away from the sun. So the cold side of the building without openings, or with very minimal openings, just to make sure that there's no, you know, heat loss at the back. But this is totally up to you, of course, and it depends how the dimensions of your building are, and so forth, what is happening behind your building. But let's assume I did this. So you see there's a window here and here, and this is a door here. So this is the first rough idea of how I would be placing this. And then I'm going to start looking at what am I looking at? I'm looking at bracing, and I'm looking at, does placing the windows and doors here actually work in terms of usability of the space. So we're checking the corners first, and again, you need to have a minimum of 900 millimeters, 0.9 meters in your corners. So if we think about, one of these squares being 0.25 of a meter, you see that this corner here is not quite strong enough. So you really need a little bit more wall length here in order to have this whole thing stiff enough. Which means maybe we have to just shift the window further back, because here we actually have space to make the window a little bit bigger. But maybe we don't want a window right next to our head. So maybe this window is smaller. That's really up to you to decide. So I'm just giving you pointers into deciding what would work. I'm just making it a little bit bigger because that's a nice size. Here, in this place here, there's definitely not enough bracing, and also having the window go behind your closet might not be so nice, aesthetically not so nice. So we're making this corner a little bit bigger too. In a very small building like this, you don't have that much playing space with your window openings on the shorter sides. But if the floor plan is different, if the room, for example, is square, it's different. So just check this out. So and this works. Yeah. So this is how I would do it, drawing by hand. So I would think about first playing around with furniture, then placing the windows, and then tweaking tweaking so that you have enough stiffness in your corners, and so that you can be sure that your traffic ways, the way you come into the building, the way you sit on the chair, and so forth, works, and that it actually works in terms of accessibility of windows and so forth. And if you decide to have a sleeping loft, so let's say the bed is not there anymore, decide where you're going to put the sleeping loft. So let's say, I want to have this bed up in the sleeping loft, this bed here. The sleeping loft has to be at least this size. So you see here, you don't want the situation where there's a window opening right under. You can solve it structurally, but ideally you have a good support under your sleeping loft. So I would suggest you just extend this wall a little bit more, and then you think, how do I get up into this? So instead of having the cabinet here, you could have the ladder here, for example. So that's a possible idea. So I hope this gets you thinking. And I will just hop over now to the Floor Planner app, and we'll have a look at that, okay? So if you have questions, pop them into the chat as this comes up. I will go through the chat in a moment and answer questions. So I think for this I have to go, because it's online, I have to go over. So I will not see the chat right now. But when you sign up, so you create a free account for Floor Planner and you log in, you come to the dashboard, and then you go to projects, okay? And you go on to create project. Create project makes a new project. I think I already did this yesterday when I was setting up. And you go on to empty plane. And it brings up the graph paper the way you would have it, just online. And then I would suggest you go on to draw a room. And what I like about Floor Planner is that it asks you all these things at the start. It's very simple. So, let's say this time around we are designing for mud bricks. So they work in centimeters, 280 millimeters, 28 centimeters. They ask you about the wall height. So I just put in 2.4 meters because that's a standard wall height. It doesn't matter because you're working in 2D at this point. And then it's very simple. You just go over, you click, and you drag. And it doesn't matter really what you're doing at this point. Just click and drag and let it go. And then you can adjust the measurements here. So I want to show you another size of building that works within this 10 square meter floor area that works, being 300 centimeters, so 3 meters. You have to click enter. Times 330, 3.3 meters. And I'm using these measurements because that's the actual measurements of within the block module. So you can make it a bit bigger so that you see it. And when you're designing, it's good to put the measurements there so that you know what is going on. And then in Floor Planner, you have the options of then placing doors over here. So let's say we're just grabbing a French door here, and then you can go over and place windows, and you're just placing 2 simple windows here. And then what this allows you to do is it allows you to play with the size here. And if you look at the outside measurement of the corner there, you can go down to 0.9, and that gives you a strong enough corner. And then here we might leave it, and here again we check the corner, make sure that it is it's a minimum of 0.9, but I also actually what I'm checking is that it is within a brick module, because I don't want to cut bricks so much. So 0.9 works. I'm going to maximize the door on that side because it's nice to have a nice big door. You can also click on the measurement, I think, and then put it in manually like that. And here, just to show you what I meant with the size, if you look at that measurement on the outside there, which at the moment says 1.11, that's not within brick module. So the brick module is a multiple of 0.15. So you would have more than 900 would be a 1.05 or a 1.2. So I'm going to go to a 1.2. And on this side, same thing. I'm checking 1.2. Like that. So I know that these walls are within brick module now. So that is that. And then you can go over to the left and you can see over here objects. You can go and grab furniture. So for example, bedroom furniture, and you just grab them. If you go to beds, for example, it will give you double beds. You can choose what you like. Doesn't really matter, in 2D, but you just choose something like this one. And you start placing it. And you can go and grab other you can go and grab other types of furniture from the objects and place them in here. And you see how in this size building, you kind of have different options in terms of putting in furniture. That this might be like a nice thing if you just have a sleeping room with walking space around. You might be able to place a small chair or a freestanding coat hanger or a lamp. The 3 times 3.3 floor plan feels quite different in terms of the room. So I'm just encouraging you to try different dimensions and see what happens when you're placing furniture, and really start visualizing how that would look and what you want. So that's where the architectural or the design aspect comes in. And when you're happy, you just go on to export image, and you can export it, or you can take a screenshot of that and then you can share it in the group. Okay, so I think that is as far as I want to show you with the floor planner. Yeah, and whether you're designing with the floor planner or by hand, at the end when you're happy, for now, just take a screenshot, take a photo, somehow share it in the group so that we can compare notes. And it's going to be really exciting for me too to see what you come up with. And if you want to have feedback to it, let me know. It can become a little bit a personal thing, so I'm not going to critique your architectural design at all. If you want feedback, please note it with your sketch, and I can give you some pointers. I can point out, practical things and ask you more questions, and you can fine tune it. So, with that being said, I'm just going to suggest a couple of things. Just put it on this screen here so that you see what I suggest in terms of assignment for day 2. So, draw a 10 square meter floor plan. It can be bigger if you really want to. So, I don't mind, but stick maybe with the 10 square meters if you're a beginner. Make sure you include all the wall thicknesses and the openings, so the windows and doors, and that your the furniture works for what you want to achieve with the room. Check that you have adequate corners for the bracing, and then take a screenshot or a photo and post it to the group. So that's the assignment. Sweet. Um, And the other thing that I would like you to do if you want to take part in tomorrow's training is that you get your standards, so the free downloads of the Earth Building Standard 4299 version, which is free for download, so that we can start looking at that, especially if you want to design for heavy, solid earth construction. And you certainly will need the timber frame building standard 3604 2011, which is also free for download. You'll need that for tomorrow because we'll be looking at roof structure. And I just want to start training you not to be scared of looking at standards and understanding how they're laid out so that you then can use them for your design, because they contain everything. We can't in depth cover everything. So, there were questions about foundations, and there's many different options of doing things. But I want to get you thinking about everything, and I want to break the ice of you looking at these standards and starting to understand how to use them so that you can then carry on designing. And that brings us to the end of the live stream as such. So I'm just going to stop sharing. I'm coming back on and I start looking at your questions. Okay. So I just see this thing at the last comment. The size of the adobe brick, the minimum size of a load-bearing earth wall, be this adobe block, rammed earth, cob, is 280 millimeters. So the nominal size of the adobe brick is 280 millimeters if you're using that for your wall thickness. Can you do a circular floor plan on the app? I don't believe you can. I looked at a couple of other apps that looked a little bit more complex to just pick up off the cuff, which did circular. They had the option of doing circular, but you can sketch this by hand without the app. So if you're going into organic shapes, I really would encourage you to hand draw that. Can you do round walls with Adobe Block? Yes, you can. The only disclaimer here is that a round building or curved walls, they're not covered by the standard that doesn't require a specific engineering design. So all the nice round buildings you see around, small buildings, they're very solid and strong. Strictly speaking, they would need an oversight of an engineer, and some of them have. There's engineers in the natural building movement for sure. Smaller buildings are stable, but some of the rounded shapes you see, especially in combination with sleeping lofts, sometimes are actually not that safe, depending on where the openings are placed and how many openings there are and so forth. So really wanting to say, if you're serious about building a round structure with solid earth walls, I would really recommend, especially if the building is bigger, that you get it checked, because the bracing of the building is a little bit more complex. You can't just follow that cookbook step-by-step calculation that is in the Earth Building Standard. If it's not straight walls, the actual engineering of that is a little bit more complicated. And yes, round shapes are strong, but they're not that strong if there's lots of openings. So I'm really encouraging you to get that checked. A lot of the rounder buildings you see around actually have a post and beam structure. Like the posts are disguised, and then it's different, because the posts are doing the structure holding up the roof, and the walls are just sort of sculpted around the structure. So just to clarify that. The app is called Floor Planner. It's good to know that the floor planner works with Mac. That's what I thought. So I'll just pop that into the comments on that request that I had. Thank you for sharing that. Um, is there any more questions? New ones before I scroll up? I think I'll just scroll up. I'm going backwards. And if I miss anything, I'm going through again and also putting the answers to this in writing after we finish, because then they're there for other people to see as well. So I think there's not that many questions. There might be questions coming up as you're designing. So I think we'll wrap it up at this point, and I'll see you in the group. So thank you so much for being here live, and I hope you enjoy the design process. Bye. Here, one more. How big would the floor plan need to be to incorporate a sleeping loft? Um, so the floor plan can be 10 square meters. And then you have a sleeping loft that just fits a double bed, for example. So definitely even in a 10 square meter building, there's space for a decent sleeping loft, And then under the sleeping loft, you could have a sitting area or a workstation or something like that. So think a little bit of, even looking at tiny homes online to get some ideas might get the thought process going. But you can achieve nice things even with 10 square meters. Okay. Thank you. Thank you so much. Have a wonderful day or evening wherever you are. Bye. Bye, Hannah. It's lovely you're here too. Lots of love.